Developer here. So, what is XR to you? Have you anyone experienced XR? External. So, in this title, we will be explaining like what are the different XR. Like there are actually segments like AR, which is augmented reality, virtual reality, and mixed reality. We try to touch upon like how we can build applications using AR, VR, all this stuff. So that's it. But before I get started, I want raise hands. Let's say, okay, see certain people. Okay, how many of you have tried like AR in your phones? Cool. Right. Has anyone?
People are answering. If you answer, like you will get money.
So, right. So I am an XR developer. So my primary development is actually built on Unity. So I build AR applications with the Unity framework. So under the hood, it is all just coding, like using the Unity framework to build AR applications. I'll explain a bit more about that. AR, VR, MR. There's a lot of possibilities in this area. Like it's actually niche technology. It's actually coming up very fast these days. There are actually a lot of possibilities in that segment. A lot of applications are built. So if you are interested to work in like these technologies, I can help you get started. Like what it takes to get started in those technologies. Then apart from that, we cover some like what it means to have an immersive experience. What are the factors which actually constitute a good AR experience? So we touch a bit of base of that. Then some like foundations like how we can build something in AR. We'll touch a bit about Unity AR. Even when you are not physically present in some place, you can actually create AR application, AR content, even from a remote location. So that's something Google has tried out. It's actually using Google Maps internally, Google Street View. Then at the end of it, like we'll try to create a demo AR application. Not a full-fledged application due to time constraints, but I think we can get started with the Unity and everything, so that if you want, you can explore more in that area. Right. So, what is augmented reality? As I said before, it's just overlaying virtual content and information on the physical world. So, what it helps is like it augments the real world with digital information. So, augmented reality is actually a part of like extended reality. There are other realities as well, like virtual reality. There is no physical, there is no real world. Every surrounding itself is a virtual in content. Then there is mixed reality. I would say like MR lies between AR and VR, but we call it as an umbrella term called XR, which is extended reality. Right. So we'll talk more on the augmented reality this time. So in this one, like what's the help of augmented reality is actually provides new devices to be smart. Like most of you will be using any smartphone or anything like that. So that becomes very useful. This augmented reality applications make it very useful to use the phones, and actually it assists you in a lot of ways in your daily life as well. Right. So I'm just giving an example here. So you can see kind of that's actually a virtual object in a real world. So what actually constitute as a good AR experience? So here you can see like the phone itself has if you are on the latest phones like Android 7 or above, it will have a lot of sensors. Any kind of movements, like you move, tilt left or right, up or down, or else you can move forward. All these sensory actions are actually collected by your phone devices. And based on that, there are actually concepts like SLAM. SLAM is nothing but simultaneous localization and mapping. So if you place an object at some particular location, any movements, it should be seamless. It should be always there. The moment you come forward, it should actually shrink. If you see this example, the user is actually coming forward, the size of the objects actually expands. So it gives you a like perception like that is actually original, that's real. That is what, that's the first part. So immersive experience constitutes of like 6 degrees of freedom. So if you are on the latest devices, it will have like lot of good sensors. I would recommend, like, if you have not experienced, do try it out in your phone. I'll give you an example of how to try it in your phone later. But yeah, that's one thing. So 6 degrees of freedom. So left, right, top, down, as well as depth perception, like moving closer as well as farther. So and in any of these directions, these models, the virtual models, augmented models that you have created in the device, it should be always specific to that location. There should not be a glitch like the moment you close, it should actually increase in size. So that's one thing called 6 degrees of freedom. It's also called a SLAM. The next thing, important stuff, is called occlusion. So if you create an object, it should not be a see-through object. That gives you a perception like it's not real. It's not giving you an immersive experience. So in this object, you can see a frog at the behind the globe. So it is actually more like opaque, and you can't see the see-through part of the frog until you go like walk around that. That's called occlusion, right? Plane and surface detection, we'll create a demo and we'll see like how we can create a plane detection algorithm and things like that. So that's more important. Like if you are placing a model and some portion of it is below the ground, you will not get a good immersive experience. Right. Apart from that, there is something which is soft spoken, that is called ambient lighting. So this lighting condition, like if you place an object, it should cast a shadow. If you can see at the bottom, you can see some shadow occurring. The light is more, it actually senses like which side the light is coming from. So if it's coming from the left, the shadow should be on the right. It will feel odd like once you create something without ambient lighting conditions or casting shadows in the wrong direction. Right. So how to build something with this? Have anyone experienced so far? Like creating an AR app? Cool. You'll get a gift at the end. Right. So in my experience, I have been using in the past 3 years, as an XR developer, I am using Unity as the main framework for development. This is called Unity. Unity has something called AR Foundation. That's actually a package which constitutes of 2 things, like ARCore as well as ARKit. So if you are developing an AR application which is Android specific, this ARCore comes into the picture. This provides you all the APIs, going back to the previous slide. It gives you the APIs for example like degrees of freedom, SLAM, occlusion, plane detection, and everything. So ARCore is the important package for like in the AR Foundation for Android devices. Similarly, there if you are in a iOS ecosystem, it provides something like ARKit. So AR Foundation is actually a wrapper on top of this. So if you want to build for an Android device like an APK, it uses ARCore in the backend. Otherwise, if it's an iOS, it creates an ARKit. Right. So why Unity? Like, has anyone thought of that question? Why Unity is better? You can actually build AR applications with pure Android. You can create applications with different frameworks like Unreal Engine. There are different other frameworks also. So from my experience, Unity is one of the best game engines. Not because it's the best. It provides you a lot of capabilities which are best suited for augmented reality and virtual reality applications. So as I said, it's a game engine. So fundamentally, this was a framework developed for creating games. So what it means, like it's a game means it provides you a lot of libraries out of the box. For example, I'm just giving an example. It provides you a library called physics. So all the physics calculation, you want to throw something, it should go a parabolical way. Or like if you collide on 2 objects, it should have an impact and go back. So such animations, everything is possible with game engine. So that's why we prefer game engine. And Unity itself supports like 3D. So which makes it the best, one of the best choices for creating an AR application. But this is very opinionated. Unity is not the only one. We can create plain AR applications with Android as well. but it will be a little bit more complex. You have to piece together all the pieces together. So it's difficult, right? As I said, Unity provides the Unity framework. It provides an IDE which is actually designed for 3D application development. Right. So ARCore, it's using ARCore for Android applications. Similarly, ARKit for iOS. So you can get more references of that in the code labs, googledeveloper.com. The reference is available. Right. So this time in this session, we'll be covering like what it makes to position some object in the real world. So positioning, or also known as anchors, it's actually like a frame of reference. Like where you are looking at, that should be the reference of that object. So even if I am moving away, the object should behave accordingly. So there are, as I said before, there are sensory motion sensors in all the devices. So that's how when you look closer or walk further, all the positions are calculated like that. Right. So this is how we are positioning. You can so Unity, as I said, Unity is a 3D application, so it has 3 coordinates. So you can place like x, left or right. There is y, top or down. Then there is depth, how much distance it should be there. Apart from this transform positions, there is also something like looking for the pose. Is it looking back? Is it looking? You can place an object, but how it should behave? Is it looking with respect to a device? It's looking front to you or like left, right? So Unity use something like position, like forward positions, and then it looks back to you. Right. So I think knowing at the audience, like it is very less experience in AR. So if you have your Google like Android devices, I'll take a quick 2 minutes. Can you search something like tiger or any kind of animals in your Google, so that you get an experience of what AR is. Maybe I can do it as well parallelly. Okay, so let me also search simultaneously whether my support, like Google supports, my device supports AR application. If you have not experienced, I would recommend like it will give you a good experience. And if the AR is not supported, then that's actually time to upgrade your phone. But yeah. Yeah, so Google has this experience, like in your Google search, you can see something like view in 3D. So let me try view in 3D. I'll view it in my space. So this is what it is doing. You can see what I am experiencing, right? So first what happens is it actually detected the plane and it's actually placed that object on top of it. So what I am seeing in my screen, it's being projected. So this is what is called AR. So it should not stick, like its leg should go down. So all these parameters, what we described before as an immersive experience, that's most important, like in an AR app. Cool, all experienced? Okay. Right, so that's what actually this game also. So what I'm doing is I'm actually looking at the surface. Once I understand the plane or detected the plane, I actually place some characters there. So this is actually more evident in any kind of AR games. Okay, so has anyone played any AR games first of all? Okay, which games? Pokemon Go, yeah, good. Pokemon Go. Okay, there are a lot of AR apps apart from Pokemon Go, but you give it a try. Right. I'll move to the next part. So as I said, like positioning or first important thing in any application is like positioning or anchoring, placing the objects in a real world. So there are actually different types of anchors. Anchoring is just positioning. So one is called world origin. Then the next one is called planes, horizontal and vertical. So the previous example that we have seen is actually plane, and it detects the plane and it places the object there. That is like planes and planes, plane anchoring. And then there are actually other forms, like there are actually other frameworks, APIs, algorithms in place. So you can actually anchor it to some image. Then there are actually something like face anchors. Face anchor is like sticking onto your face. And then there are different types of called spatial anchors. So this is spatial anchors has a lot of possibility in any kind of like development environments. So I'll cover each of bit in depth. So world origin. So primarily in my experience, like this is one thing. It will, whenever you are looking, if you are using a head mounted device, something like this, so you need to run some applications in front of your eyes. So that's where we like at a distance of 1 meter, looking back at you, it should place some objects. In this example, I'm just placing something like a cube or something. But in actual scenario, I can create different kinds of applications, and it will be world positioned. So once I am positioning it there, the movements of my it is relative. It will be always fixed there. So this is the more common for like different kinds of applications, like in AR applications in my line of work. I'll explain a bit more in the demo part, but like plane anchors. So plane anchors has a lot of use case in kind of like consumer markets. So one example that we see is actually plane anchoring. So it was actually able to identify the horizontal plane. The plane is actually right in front of you. It identified that and placed the object there. So similarly, the like lot of consumer applications. So the right side example is called IKEA. So how it actually provides is when you are buying furniture or any kind of thing, it actually gives you an experience like how that furniture will look in your actual home or in your place. So it will identify with 98% accuracy. That's what they claim. Yeah, and it is possible also. So it detects the plane, it creates an object of that particular dimension or size. So you can identify like a stool or table or desk. Anything will look in that much in that area. So that is plane anchoring. Plane anchoring has a lot of use cases in case of like consumer market, consumer applications, where you want to experience like how it will look. For example, dress. Anything is possible. Right. So image anchors. This is one of our earlier projects. So so if you want to stick this digital content onto a image. So in this example, we are using a book as a reference. So this digital content is actually always placed on top of the book, irrespective of where you move. It's not tied to the point of where you are looking. Right. So you move the book around, and the digital content also move around. So this is one interesting. Basically, this was one of the starting projects for ThoughtWorks also. So what we build is something like a bookstore application. You look at any book, it will scan through what is the book content. It will give you all the ratings. It will give you all the reviews. So it helps me to identify what books should I choose as a reader. So such applications are useful for image anchors. Right. Face anchors also has a lot of use cases. In case of like Lenskart, if you want to trial out something, face anchors is the right thing to go for. Right. It's actually positioned to the face, not on a plane or like world origin. It's actually positioned to the face. Right. So this is one interesting area which is actually more getting more generic nowadays. So it's called spatial or cloud anchors. So there will be multiple users, collaborative users. They will be having different devices like head-mounted device or a phone or a tablet or a PC. Anything you can place a content and they can correspondingly like work on top of that, view it simultaneously. So that is called spatial anchors. So in this, the AR experience is not shared with just one user, as in the previous case, but it's shared across multiple users. So one user can look at one side, the user can walk around and look at the other side. It gives you the perception of like a common object there. So
for this spatial anchoring, there are actually different ways how to achieve spatial anchors. First of all, the first user who places the object need to share what is the object to other users. You can share it locally, that is also possible, but these cloud platforms, with the boom of these cloud platforms, there are actually a lot of APIs where they can detect the object pushed in one of the user and share it across multiple users. So the top actually comes from like Azure Spatial Anchors. Google is also high into that. Like Google Cloud Anchors is one of the very popular cloud anchoring positioning objects. Is for positioning objects. You can get those references. As I said, like even you don't want to be physically present in that place. You can actually place objects from a remote location. For that, we have something called geospatial. So that is actually a new feature. Do try it out if you have not explored. Right. So how does spatial anchors work? So as I said like before, in earlier scenarios, once one of the users places the object, it actually shares some knowledge, some information to the other user, saying that the object is placed in such a location and it is facing in such a direction, right? So so first user, once it places it, it actually sends some data like this. This is the surrounding, and in this surrounding, I am actually looking at the object from one particular angle, and it will share that knowledge to the cloud. So the other user will get those knowledge from the cloud, and it will also scan the environment. For example, if one of the user is looking from here and the other user is looking from the other side, it should scan and it should match accordingly. So for that, there are actually something called scanning. It will scan all the environments, all the touch points. If you see the right image, it's actually scanning all the points. And depending on what kind of points it is and the view of from where you are looking at, it actually places the object accordingly relative to each users. So this has very lot of business use cases, like in case of like engineering field or any kind of like constructions. All these use cases, this collaborative experience can be shared using spatial anchors. Right. So some of the AR use cases which we developed, one is called like wayfinding. So I am in a new place, I want to know search something. It provides you the path inside. For example, this is the first time I am coming to Forge. I don't know where is this auditorium, everything. So if you have something like an application which guides you, you need to go left, go right. So that will help. This is one of the previous application was developed a few years back actually. And as I said, like book application was another application which you scan, you take your app and scan. The moment you will get augmented reality contents, like what is the rating of that book, what kind of genre it is, everything, all the details, whether it's a thriller, all the stuff, and also it will give you more information. So we were developing on top of that for more. These are some AR use cases that you can think of. It need not be like a corporate level. You can also create for fun, like this kind of applications where it scans the picture and gives you information. Right. So enough of talk, enough of literature. So before we jump into the code, like how it is done and stuff, any questions so far? Is it clear for everyone? Okay. Right. Then let me quickly share the code. So in this, actually, I am creating something called a surface game. So first, I am using Unity. As I said like before, I am a big fan of Unity. So in this, okay, I'll just give it 2 minutes. I'll just explain what is Unity editor, how to build applications. I see like very less people have tried this. So just give it this time. Right. In the meantime, I'll just explain like what we are trying to build here. So what we are doing is in this code lab, we are trying to build something like this. Okay. So first of all, we need to identify the surface, that is like plane detection. There are actually applications, and this Unity itself provides a lot of physics. So I need to know on the surface, I need to place a raycast pointer. This blue icon is a raycast pointer, and whenever hits the raycast is something like you look at from the camera direction and from the detected plane, it identifies the point and it places the object in that area. So after that, we have created a car models and things like that. We will not be able to cover entire due to time constraints, but we will try to cover at least the plane detection, what it takes. So we will touch more on like how to build something in Unity, since Unity itself is new for everyone. Right, so over to Unity. Right, so this is ideally a Unity editor. In Unity editor, there is actually some view called a scene view, or called as or a game view. So in the left hand side, you can see like a hierarchy pane where you can create new all these objects, or all this, if you think of like web application, div is a building block. Similarly, in Unity, everything is called a game object. So anything that you want to place, it's called a game object. There are different game objects in the scene. This is a sample scene. I have created game objects called AR session. Yes, I can create any kind of game objects. I'll create a simple 3D object called cube. So this is the cube. I can, as I said like before, I have a x, y, z direction. I can actually place, drag and drop. Anything is possible with Unity. And the moment I start viewing it, it goes to the game view, which is for how the game is played. As I said, it's a game engine, but don't get like confused, like it's just for gaming purpose. It's also good for AR applications. Right, so I created a cube object, so you can see the cube object in the XYZ coordinates where I placed it. Right, so I can move around, and you can see the game view, it is actually moving around. Right, so this is one of the scenarios. So this is Unity. I will just explain a bit more on what is Unity. As I said, like all the things are called game objects. So whenever you can create empty game objects, or any kind of 3D object, any kind of lighting. This is very useful, lighting, audio. Any kind of objects you can put it in the hierarchy. Then that becomes your 3D contents. Right. So and in any of these game objects, right, if you go to the double click on it, it will provide you something like an inspector. So inspector is nothing but what is this game object containing. So here by default, when I drag and drop a cube object, it provides me something like these are the properties of a cube. Properties in actually is called as something called components. So a cube has a component called mesh. So cube has a surface, sides, corners, everything. So we usually see that you need a mesh. Mesh is like to see it. In the plane detection also, we'll in the previous example that we saw, once we detect the plane, we wanted to identify, we want to visually see like this is the plane detected. So we have created a mesh on the surface detected, and we applied some materials on that. That is the dirt material that you see. The floor is actually not this dirty, right? So so that's something. So you can add any kind of properties. For example, this has something like, as I said, like it's a game engine, so it gives you different components like box colliders. It's just for colliding purpose. For example, you collide two cubes, what should happen? We don't want to create animations for each and everything of this behavior. Instead, we can use Unity's inbuilt game engine capabilities. So you can create any kind of components like box collider, capsule collider. So it will create a collider surface on top of that game object, and whenever something hits, it will. So if you think of like any kind of games like where you shoot something, so that is having some collider. The raycast actually points one object to that, and that's how this game actually works. Right. Any questions so far with the Unity editor? All clear? Okay. It's a very short duration to learn in depth, so I'm just quickly continuing with that. Right. So this is just a cube. I'll just remove that. Right. So similarly, you can create an empty game object. So game object, it will have only a transform. That is like what this game object, where it should be positioned. You can give x, y, z, give a rotation, like it's just ankle it somewhere, like rotate some degrees in the x-axis, y-axis. Then and the scale also. By default, every scale will be 1, 1, 1. Right. Apart from that, in the project, there is actually a project window at the bottom. Here is where you will see like a lot of folders. These are actually different folders. So anything, if you want to package some game objects and some scripts, okay, I didn't complete scripts. So if you want to create a script is nothing but like you need to do interaction on that game object. So you can create a script. So there are different scripts available. I can create a new script also. Let me just create a new script. I'll call it like empty script. Right, let me go into that. So script is also a property of a game object. A script is like where you can actually provide, create some action. Like once you look at it, it should like explode or like any kind of actionable items. You do it on a script. Right. It takes some time. Like as I said, Unity is a very complex engine, so it takes some time to get used to it. The test development cycles are a bit high. But if you think of like Android and all, there is not much inbuilt features, but development should be much faster. Like you can test, build everything much faster than Unity. Right. Yeah, let it open. Right. So I'll cover the scripts part. In between that, you can see in the left side, I have different folders. One is called materials. The whatever should be the behavior, like content of that cube or something, right? You can apply a material like a blue texture or something like a green texture. Anything is possible with materials. So in the previous example, they gave a mud texture, like a dirt texture, to the detected surface. So once they detect the surface, they create a mesh on top of that. In that mesh, they provided applied a texture called dirt. That dirt was an already available texture, and that's why it looks like dirty or like with mud and all. Okay. Okay, let me see whether the script opened. Okay, and apart from that materials, which is actually the texture, there are actually components called scene. So whatever you see on the UI is actually scene. The scene view, here we created something, right? So that's the scene view. It's a collection of game objects. With game objects will have like different components like scripts, other box collider or physics features. You can even apply gravity, like this behavior. This game object should apply gravity, so it can you can have a free fall kind of behaviors also. Right. So that's scene about. Apart from that, there will be scripts folder where you have different scripts, C# script. So this is where we will write the code. There is something also called prefabs. Prefabs are like templates. So if you want to package all this game objects, all the combination into some the one you see in blue, right? That's actually a prefab. So prefab actually is like you collect all the components, you package it, and then make it into prefab. Prefabs are like templates. If you think of it like, it has like some game object. It might have some game object, some scripts attached into it. You can export this prefab as Unity packages, so you can import in another project. So that's how they share. Yeah, I missed one important thing. So okay, versions, I think it's streaming, so my system is getting slow. So you might have seen different package managers. Most of you might have know something like NPM, right? What is NPM? Node package manager. Similarly, Unity has also its own Unity package manager, UPM. But in the backend, it is actually nothing but just NPM concepts itself. So you can have, using this package manager. So there is actually similar to NPM registries, right? There is something like I should stop streaming, I guess. It's very slow. Just hold on a minute. Right, so similar to Node Package Manager, we have Unity Package Managers. So this Unity Package Manager, you can import this Unity packages. As I said, like it can consist of like different prefabs, different game objects bundled into some Unity package. So there are actually different packages already available in the Unity registry. The common one that we explained in the PPT, right, that is AR Foundation. So AR Foundation itself come as a package in the package manager. You can import that. I think we can't go with Unity. It's very slow. Right, we'll go with the code lab then. Okay. So in this project, I have imported AR Foundation, ARCore XR plugin because I am primarily using Android phone. So I only need ARCore. If you are using developing applications for iOS ecosystem, you will need something called ARKit. Right. There are other components which are useful for me, but just skip this part. So this is how you import new packages in Unity. There's a Unity REST. It's similar if you think of like if you know NPM, that is similar concept, but in terms of Unity. Right. I'm so sorry, but I don't think we can continue with Unity editor. So we'll go with the code lab examples. Right. So first thing is Unity itself is a heavy application. So if you are using like personal computers which does not have that much graphical support, it will be difficult to stream, difficult to use Unity. But if you have like good high-end game development laptops, like game engine laptops and all, with good graphics and all, Unity should be smooth. It used to be smooth here, but I think I am streaming online in the virtual content. That might be the reason why it's getting stuck. So we'll cover with the code here. Yeah, now it's smooth. So what we need to do is something and at the start we need to import something like AR Foundation, and that is a package manager in the Unity package manager. Then you need to import three things basically: ARCore as well as ARKit if in iOS is required, and then apart from that the AR Foundation. So once you develop import that you can create any new project. Install the necessary AR Foundation, ARCore if that's required. As I said, like they have they have exported it as a Unity package, some components. You can download the starter package and import it. You will get some prefabs already within this. You can drag and drop these prefabs to your Unity editor to create an AR application. Right. So yeah, as I said, Unity is actually a generic framework. You can build Android application platforms. Similarly, there is PC, Mac, iOS standalone. These are the different platforms options available with Unity. If you are only building with Android, go for ARCore alone. Right. So building should be straightforward. At the end, it's first step is actually to get access to your camera. Maybe I can share that with the video. Right. So in this one, this application, what I have built is actually I just try to whenever I wander around, I just want to detect the plane, and then detect the plane, I just need to make a mesh out of that. So mesh is actually like it's not visible. Oh, sorry. Yeah, you can see. So the moment I wander around, it detects the surface, and it actually applies some material called dirt texture, and that's how you identify the surface. So on top of this, I can actually place different objects. Once I identify the plane or the surface, I can actually create new objects on top of that. But unfortunately, we can't build the Unity game now, so that's fine. Right. Right. So there is actually code lab available for you. If you are getting started, just try with the code lab examples. You can actually detect the planes in real world. Just go through the code part quickly. Right, so you can configure these planes, you can create new objects and place it in the scene. Right. So at the end of the app, what I'm sharing is something like this. Okay, right. So it actually detects a plane, it creates a dirt texture out of the detected plane. That's how you see it. The next part is like once you identify the plane, the next thing is you need to place objects. So how can you know you detect a plane, but how can you know like I am looking at top, down? We just need to place the exact object at the exact plane detected location, right? So for that, what give me a minute. Right, so I created a reticle. It's a reticle. It's in circular shape. You can create your own reticles like a quadrant or anything. So once you create a game object in this format, like you can create like ring kind of game objects. Previously we tried cubes, circles, spheres, everything. So we can create a smaller sphere at the center. You create a ring at the outer of the. You position the ring outside of this sphere and a bigger sphere that can create your reticle. This is actually a game object. These are pieces of game objects in Unity. So once you create a model, this game object model, what you need to know is like you are looking at a surface from your phone, right? So phone has something called camera direction. So camera is what you are actually looking through. This camera only you are viewing the contents. So initial step is to identify like how much distance it is, in what direction it is. So and we just need to identify the exact point where it hits. So what it does is we get the access of the camera object from our phone, and from that phone it will you will get the direction as well. So which direction it is pointed. So I am pointing one point, say, or a distant point, and from there it will create a raycast. Raycast is something like these are actually APIs in the Unity game engine. You can identify which point it is traversing and able to identify which point I am looking at in the detected surface. So once you identify the detected surface, you can place the object at there. That's how this is actually done. Right. So once you identify the dirt like the surface, you can actually create a game object. And the moment you are actually moving forward, the camera direction also changes. So the moment you look around, this camera direction changes and the reticle also follows you. So how to make that reticle follow you? So as I said before, my rider is not loading. Right. So sorry, I'm not able to go to the code. Right. So in this, there is actually a method called update. So all these scriptable objects, right, in Unity, it has actually, like in Android, there are actually different life cycles. Once you start application, it calls like on create, on start. Similarly, when you like close an application, calls on destroy. So there are different lifecycle methods for Android activity objects, right? Similar for that, Unity also, all the scriptable objects has a lifecycle. So you can, there are actually methods called start, on start, what should happen on start, and there are methods like on create, awake, on create. These are different life cycles. What we are interested in is something called update method. So update method is, Unity is actually, so in this application, AR application, you have a concept called FPS, frames per second. Like if you think like frames per second, like if you are watching a video, so video is actually a continuous frame, frame per frame, and continuously shown one after the other. So a typical Android application has FPS called 60 FPS. So 60 frames are actually continuously shown to you. That's how you see like it is continuously, it's a continuous feed or like a camera. So this camera feed is actually getting the content of the camera feed is actually projecting at a speed of like 60 FPS. So on rendering on each frame, this update method is one of the lifecycle event in Unity. This update method calls. So what should happen in that frame? So that is one lifecycle event. So in this update method, what we are getting is, we are getting at this point, like where is my, we'll get the screen center. If I am at this fraction of a second, I'm looking at say 1 point. I'm getting that point using the cameras, and then I'm getting the center of it, 0.5, 0.5. And at the end of it, I am creating a raycast. This physics, already Unity has something called raycast. Raycast is one of the features. So from that direction, cameras, angle, direction, everything, I create a raycast and identify which point it is hitting on the plane. And once it identifies the plane, this is the hit point in the plane, and post that I actually create the reticle object, place it on the frame. This actually continuously happens on a update method. So it's on a frame per frame basis, this update method is getting called. So that's why whenever I move around, it's actually sticking to this kind of behavior. You understand what is update methods, how it's getting dynamically changed, right? So one always in Unity, like update method is actually a costly operation. It actually calls on a frame per frame basis. You should not do a good computational logic on a frame per frame, because at each frame this computational method gets called. So if there is a huge computational process overhead, within that 60 FPS, right, 60 frames in a second, that is 1/60th of a second. If within that time, if you are putting a large complex code base in that update method, the application can get delayed or laggy. So these are some tips and tricks how you can avoid like while building AR applications, right? So far like clear like how you are creating like following reticle around you, right? So the next step is to create a car. So we are creating a car object. This is also another object. That object is actually set to that also object has also called a update method. The corresponding script of that object will also have an update method. So in this update method, I am actually asking the update method of that car object to follow the reticle. So it always follow to the reticle. Here I am also creating another application, another game object called GIFs. So what this is actually doing is, the moment the GIF box appears, I can actually look to that using the reticle. I can actually look at the game that one, and the moment it increments, like the moment I collect it, it actually randomly pushes it somewhere else, right? So this is one thing. Unfortunately, Unity editor is not available, so you can't build it. But if you are interested in to build something like this, there is a code lab available. So you can actually easily make it. I assume like most doesn't have a lab also, so not possible to build now, right? So the last part is what did we miss from the immersive AR experience? There is some part missing in this game. Did we cover all the AR experience, like immersive experience factors in this game so far? Right. Lighting is the last part. So we are actually casting a shadow. If you see like casting a shadow, we don't know. This gift box has a shadow at the back, but it may not always work. So if the lighting is here, so if you are placing just below this, the shadow should be below that. So for that, to get a good AR experience, lighting is the last part. That is an important part also. Otherwise, you will feel odd playing the game, right? So lighting is the last part. there are actually there are APIs available. It will detect like from which side is the brightest in the scene. So if the scene, if the light is brightest on the right side, it will cast a shadow on the left relative to the object. So lighting up, setting up the lighting is the last part. There are actually directional light. You can actually always focus, like the direction will be always from the front, then the shadow will be always at the back. Instead of that, you can actually use ambient lighting situations as well. So depending on the scene where you're viewing, if the light is come more at the right side, the shadow will be cast at the left, and vice versa. Right. So this is the last part where we configure the lighting session. And after the lighting session, you can see it is more immersive now. You can see the shadow is now at the more light is at the back side, and in case of like dark environments, there is no shadow at all. Okay. Do try it out. Unfortunately, we can't build on the fly. Right. Any questions so far? Right. So how was the experience in the AR? Like, any thoughts? Like how we can think of like improvements in AR? Okay. Right. So that's it from my side today. So going back to the agenda, what all we covered today? Can we have a quick recap?